I'm going to give you a quick rundown on adding RF connectors to USB Wi-Fi devices or any kind of device. Here I've taken apart a Linksys wireless G network card. I think the model number is WUSB54G. Here's the circuit board. It had one screw underneath right here. If you can't figure out how to take it apart, you shouldn't be doing this. The absolute necessary tools in this is you're going to need some solder, of course. Desoldering braid, usually a must. You're going to need some kind of utility knife. There are two types of wire cutters. These are standard diagonal cutters. These are actually strippers and cutters. There's an adjustable nut on the side that allows you to select the gauge of wire that you want to strip. You want to set this all the way back. Reason being is, here's some LMR 200 coax cable. Now I've already explained on different types of coax cable, no, you cannot use RG8, RG6, or any of that other crap stuff that the satellite or cable TV guy left behind. Yield what I have said about coax. Anyway, here's LMR 200. If you take these diagonal cutters and you cut it, it's going to pinch that center conductor. If you use these, it's going to cut it in a square instead of pinching it flat. Once you actually get some coax and you start cutting it, you'll actually understand what I'm saying. Some kind of needle nose pliers are relatively required. You're going to need some kind of coax crimpers for the coax connector that you're going to be using. Today, we're going to be using an a reverse polarity panel mount SMA. What makes it what they call a bulkhead panel mount is the fact that it's got this little screw on it. So you can drill into your object, to your device, and then take this little nut, screw it on, and that's how it's going to affix to the device. And then of course we got the crimp collar, and the crimpers have the appropriate crimpers for the RP SMA. Here's our little center pin. Now I'm using LMR 200 because LMR 200 and LMR 400 are the two easiest forms of microwave coax you can get your hands on. Like I've said, I've taken this card apart. Now I'll try to show you, but you see right here, this is your antenna. Look at this rinky-dink shit coax. Yeah, it'll work with its built-in antenna, but perhaps you want something a little bit more powerful. Now if you look on this board, can you see how there's a center conductor and then there's the two side conductors for the shield? It's like this coax, like they designed the circuit board so you could fit this on directly. It's like they wanted you to mod this. But if you can't get your hands on any kind of LMR cable, you can just crack this antenna open, desolder the antenna, and then solder your little coax to whatever antenna. So if you have a helical or a biquad or whatever antenna, you don't have to go out to a connector. You can literally just glue this entire card to the ass end of any kind of antenna. Now I'm going to go ahead and I'm going to remove the sides, which are the shield, and the center, which is the conductor. By the way, having a soldering gun for the coax is a good idea, and a 35-watt soldering iron for the board, for the actual circuit board. So I'm going to go ahead and I'm going to go and start work on this. There we go. With a little bit of brute force, I was able to easily pull that off. Notice the center conductor. That's your signal wire. That's the actual signal of your card, and those two outer conductors. These two outer conductors on the sides, that's your shield. Your coax is going to snugly fit in there. It's just a matter of stripping your coax appropriately. So I'm going to go ahead and strip my coax appropriately and pre-tin it with the soldering gun or the iron, and then solder it in. Here we have the final, well, halfway final product. Wire soldered on. Now be very careful, because if you put too much pressure on this joint, if you do that, you could break the printed board, clear off of the circuit, and then your card's good for shit. So this is step one. The second step of this, really the final step, is putting on the appropriate connector, which is whatever connector you choose, either N, RPSMA, RPTNC, as long as the appropriate RF connector, and then mounting it in the case. I'm going to go ahead off camera. I'm going to go and finish this card up. Now, if I haven't mentioned that the coax isn't very flexible, so when you're actually trying to figure out where you want to put your connector inside your case, make sure that your cable will flex into the direction and into the positions that your card fits inside the case. This actually has to bend at a very sharp 90-degree angle and then another 90-degree angle, because I want to put the jack and the ass end of the card here. So that's going to need a little bit of finessing and finagling. Now, I've been using the soldering gun for the coax, and I've been using the little iron for the center conductor. At this point, when you actually have the all of this together, I'd run a continuity check between the shield and the center conductor. Also, this up here is also considered shield, so you can also, if your shield pads break off, you can also use this RF shield at the top or any point of ground as a shield. But I would use this RF box, this nice RF shield up here. Make sure you have a continuity test. Make sure that your signal wire isn't actually crossing with your shield, because if it is, your card ain't going to work for shit. So I'm going to go ahead and I'm going to go and put my connector on and work this thing back together into one usable item. Okay, took a little bit of work, took a little bit of effort, took a little bit of time. Here it is. We have a reverse polarity SMA crimped onto an LMR 200 leading into a PCB of a Linksys USB-G Wi-Fi card. I drilled a hole in the case, right about here. Honestly, if you're going to get this card, move the hole over a little bit. I made it a little too close. Now it's just a matter of putting it all back together, and that's it. Getting the appropriate antenna. If you don't have a pair of crimpers can be a little expensive. You can go and get a socket bit, an everyday metric socket bit, and get one that'll fit slightly over the top of your coax. Cut it down the middle, bisect it in two, and then using a pair of pliers you can use to crimp this. Amateur Logic episode 12, I believe, either 12 or 13. I'm pretty sure it was 12. Check out their show notes. And I did a segment on how to do that, so I'm not going to cover it here. I'll just go ahead and link to the show notes in that. I'm going to go ahead and put this back together and show you the absolute final product. Here we have the final product. Linksys card, USB, reverse polarity SMA. From here you can go to whatever antenna you'd like. This also goes for practically any device that already has a built-in antenna. You can go and get a video scanner or another Wi-Fi card or a Bluetooth. If it's got a fold-up antenna, if it has an antenna of any kind whatsoever, like one of these, you can modify it so it has a radio connector. There you go. Fuck off.
Well, if you haven't noticed, a lot of my segments are based on mobility with computers, whether it be getting an internet connection where you normally don't, or getting power from devices that you really shouldn't. Today, it's going to be about conserving power. If you've been on the IRC or the forums, I'm sure you've heard me bitching and complaining about my new laptop that I got. I get about an hour on the battery life, if that, when it's straight out of the box, just their configuration. So there's some little tips and tweaks that we can do to try and stretch a little bit of extra power out of that battery. I'm sure you know one of the things you can do would be to turn off the Wi-Fi and the Bluetooth if you don't need it. Another thing would be to dim the screen. Set the hard drive to spin down after a while, that helps. Any external fans, like I use this laptop cooler because my laptop runs hot. Turning off any extra fans if you don't need it, that helps too. But today I'm going to show you a program that's really made a huge difference. It's called Notebook Hardware Control. It's great. Go download it. I'll have links in the show notes. If I get around to it, I'll put a link up on the screen somewhere. If we jump over to the laptop, you can see some of the things. Like in the status window, It shows you the CPU clock speed, the load that it's running at, the voltage, the speed. This is designed for Intel CPUs. It's not really designed for AMD yet. They're working on it. It's still in beta. I have an AMD CPU, an AMD Tarion, so not all the functions work properly for my computer. So if you got an Intel, try it out. Tell us some differences you noticed. Post on the forums, whatnot. But like I said, my laptop runs hot, and all the software that I've tried for hardware monitoring just doesn't work. This is the only thing that I've found so far, right out of the box. No settings need to be set. It tells me exactly how hot my CPU is running, the hard drive temperature, basically all the statistics you need and everything. If you click let's see. If you have the professional version, you can set different profiles. What I like down here, it's got a little battery bar information, tells you how much of your battery's left, and if I unplug the adapter, now we got this icon here. Tells us the percentage that's left, and after a while, after it figures out what the hell it's doing, it actually gives you an estimate of the amount of time that's left. If you right click on the icon down there in the taskbar, you can click on max performance, which when you're plugged in, you're going to want, that'll make your processor run at its full speed or whatnot. Or you go down to max battery. I've gotten an extra hour out of my CPU just by doing that. Basically, it slows down the CPU frequency. I think it sets it down to around 700 or 900 megahertz on mine. I'm not sure. You can go to battery optimized, or there's dynamic switching, which basically it'll drop it down to the lowest speed, and as it detects you need more processor, it'll speed up. If you're out scanning for Wi-Fi or whatever you're doing, there's a good chance you don't need your full CPU. I mean, whatever. Another thing it has, like I said, if you have an Intel CPU, you can set the actual core voltage. Yeah, that's the word I'm looking for. Sorry, having a bad day today. You can set the core voltage. It'll do a brief test to see if the voltage is too low. If it doesn't run correctly, it'll correct it before the system crashes. If the system does crash, just reboot it. I wouldn't recommend this for total noobs. I mean, if you set your voltage too high, you're going to fry out your CPU. It's a thing best tried if you're still under warranty. And don't admit that you're fucking with the shit. But I'm sure that'll get you even more life off of your battery. Really don't know what else to cover on this program. I mean, it's something you'll have to download, try, play around with it yourself. And hopefully it extends the life of your battery, because if you're like me and you're only getting an hour on the battery, you can't do shit. I mean, you go for a war drive, you're halfway out there and your battery's dead already. So give it a try. Check the show notes for more information, or post any comments, or you can reach me on IRC. As you know, the server's irc.bsodIRC.org, or check the show notes on the website, BSoDtv.org. And hope this helps.
Hey everybody, I'm Darts, and this is the C++ Pointers and Functions tutorial. And here, if the name doesn't give it away, I'm covering pointers and some basic function protocol stuff. So, the first thing we don't know that we see is these guys. These are declarations for functions. I have the basic syntax for the actual function definitions, which is a type variable, a name for it, and type variables separated by commas, or just types, not variables, obviously, for anything that we're going to intend to pass to the functions. And here we have function commands and stuff in brackets. But for just declarations, you don't need the brackets. It's just a semicolon, because you're just telling the compiler, hey, I've got these functions, be sure to watch for them. Here I have pass reference, and two overpass functions, we'll go over all these in turn, but first, how about some pointers? Now, a pointer is a variable that really is just something that points to a specific location in memory. You know, whatever location, say, in this case, I'm going to be setting these pointers to these integers, whichever memory location that these integers live, that's where the pointer is going to point to. So I can set these ones here. This ampersand sign means the address of. So it lets us say, okay, now P1 points to 1, P2 points to 2, and we have here allows us to set values for 1 and 2 through the pointers by using the reference key, which is just the star, and that lets us say, okay, now 1 is going to be 5 and 2 is going to be 10. You'll see that later when we compile. And another major point with pointers that really isn't useful for integers, but say when we get to arrays, it'll be crucial. This is dynamic allocation. And this uses the new token. So we have an integer pointer, pDynamic. We say pDynamic is going to point to a new integer. So what this does is it allocates an integer space and lets pDynamic point right to that integer space. But we also need to clean up after ourselves when we're doing dynamic allocation, because again, it's not going to be a big deal when it comes to integers, but when it comes to you calling a function that has a dynamically declared variable in it 1,000 times, it's starting to take up a large chunk of memory, and that gets into memory leaks and stuff, where the amount of memory that your program is using just starts ballooning over time. Because if you don't delete the allocated memory and release it back to the memory pool, then it's just going to keep grabbing more and more memory. And this prevents that, and it's really good coding practice to just get into a habit of deleting it the last time you're going to use it all the time. Obviously, you need to delete a pointer that you know exists. So, for every new, there should be a delete. So, it's, I guess, dangerous to the integrity of your program. I'm pretty sure it'll just spit an error at that point anyway. But that's enough for pointers. Now for the real fun part, functions. So here we have pass1, which pass, as we saw up here, is one of our declared functions. Where are we? There it is. And here we are calling pass. And that's just variable name and what variables we are going to send to it. The types need to match up. And let's run down past the end of the main function to our function pass. See, it looks almost exactly like our declaration up here, except for a couple main things. Here we have an actual name to access the variable as, and brackets instead of the semicolon, and obviously stuff to do. So it says, hey, I'm pass, and it got X. Now, we sent 1, but we could technically send a random number, because all it's expecting is an integer value. So it gets an integer value, and it just calls it X. For the whole life of the function in this specific call inside these brackets, it knows X. And then X is just automatically forgotten by the program after this. You don't have to declare it because it's technically declared here. So here we have, it does stuff, prints stuff to the screen, and then we have return X, which I'll cover this in just a second. when I make note that here we have after pass, it didn't actually change the 1 value, it just changed the x value that it knew. But here we have 1 is equal to pass 1. This is where the meat of the return token actually comes into play. Because when you return x, you send the integer value x back. So we can have 1 equal pass, and the 1 plus 5 is going to equal 1. And we'll see that in just a second. But there's one more fun way to do this, which is pass by reference. A note up here, we did declare it with the ampersand character, which we know is the address of. So here we have pass reference, so we're passing the address of 1. And drop on down to pass reference, which is basically the same thing. I don't know why, I must have not finished my commenting. Whatever. This is going to change the x value it knows, but it's also referenced directly to the memory location that 1 lives. So technically it can be thought of as a pointer to 1, and you're editing it without having to reference it. And it just automatically does this. Another thing to note, and the rest of the functions in here are going to be void. Void is a new type. It has no value associated with it. And say we have a void function, then we don't have to return anything from that function because it doesn't expect anything to be returned. You can also not do anything like, 1 equals pass. We can't do 1 equals pass reference because pass reference is not returning anything. You got all that? Okay. So say we get back from pass reference. Now 1 has been changed by pass reference. So now 1 is actually going to equal 15, as we already have 1 equal 10 from here. So 1 should equal 15 when we get to the compiler side. And we'll see that later. One more thing to cover before we go over there is overloading functions. An overloaded function is simply a function with the same name, but different things are passed to it. They can be different variable types, or they can be different amounts of the same variable type, or a combination of anything. They just can't be the same. You can't have overpass int and overpass int. Here I have overpass int and overpass int. These two do nothing but demonstrate that you can have two of the same function declared, just with different parameters. And we'll see that it's just going to spit out random text later. This is more of a conceptual thing right now. But you can see how it can be pretty useful. If, I have the suggestion for a calculate function up there where it'll take different ints, doubles, floats, whatever. But yeah, all you coding pros out there really shouldn't be watching C++ intro segments, and I'm really not sure why you aren't skipping over it. But yes, there are better ways to implement a calc function, but we aren't there yet. So that is the end of our main function. We return 0 as per proper coding practices. And let's head on. So here's the output. It's never going to change, so I didn't really bother. I obviously already compiled and ran the code. Notice just the things we said were happening are actually going to happen. Like after pass reference, it's 15. After we set 1 equal to pass, it's 10. Yay, I suppose. This sample output, as well as the code itself, are going to be up on the show notes. If you have any questions, hit me up on IRC, and have fun. Later.
In this segment, I'm going to show and introduce GameCube RAM address hacking, made possible only with Viper GC Extreme GameCube mod chip. It is a lot. It's a lot like the NES RAM hacking and the ROM hacking I did in earlier episodes. Now you're going to have to install a chip into your GameCube, and you're going to have to put in a special high-speed adapter board in the data port of your cube. Now this will let you tie your GameCube into the USB port of a PC and do comparative address search and value search just like the NES was. Now the software is kind of poorly coded and it's still in beta, and this chip is still kind of hard to find, but if you really got a hard-on for doing ROM and RAM address hacking for any console, this is a real-time process. Now this is going to be a complicated process. I'm going to have to record a live feed from the screen captures of my desktop or my laptop, and I'm also going to have to record straight from the cube itself, and things might go out of sync a little bit, so don't bitch and complain, alright? This is the business end. This is the high-speed adapter. It's going to plug into your high-speed data port where the broadband adapter or modem would normally plug into. And this is going to allow us communications through the data bus. This ribbon cable feeds up and actually plugs into the mod chip itself, the Viper GC Extreme mod chip itself. Now this board over here does all of the communications and all the USB crap. Now this will simply plug into here like so. But what I don't like is how flimsy it is. This is really, really easy to put a lot of stress and damage on. So what I've done was I took the actual original panel and I cut a notch away where the little mini USB adapter is. That way, this will fit on nice and snug, and it'll also allow it so if my USB cable or whatever gets pulled, this isn't going to pull my GameCube or off the shelf, or it won't damage the board or that fragile ribbon cable. Keeping in mind that if you do have one of these, don't make extra long USB cables. I've had a lot of problems running like 8 or 12 foot USB cables and using gender benders and such and not being able to communicate to the cube. Try to keep your cable as short as possible and get something that's well shielded.
Start up Extreme Finder or the appropriate software on your PC side and then boot up your GameCube. And make sure you have the appropriate drivers installed, because you have to understand that now your GameCube is a USB device on your computer. So with the Cobra BIOS loaded, do not direct disk boot. Do not. That's the improper way of doing things. You have to tell the computer to start the game for you and initialize a client-host mode communication. We do this by clicking the Start Game button right over here. So go ahead and click Start Game, and the GameCube will boot up. We're going to boot up Super Mario Sunshine. Why? Because it's already in my GameCube and I didn't feel like switching out discs. We're going to use the same tactics and the same practices used for the NES ROM hacking and lobotomizing that I've done in the past. So we're just going to load up a random game, doesn't matter which one, and we're going to go ahead and start some searching. So I've loaded up Super Mario Sunshine, and Mario's just sitting around doing nothing. Now, just like with the NES, everything you see on screen has a memory address value. Now, we have a water level. If you look at the bottom right-hand corner, we have a set amount of water. Now, using the tools on screen here, we have the search initialization. Now, if you read over here, this is your general information box. This will tell you things that you need to know. Now, it says, Welcome to Extreme Finder 1.0. Use initialization search for search compare types, or search value for a specific value. Now, we're going to go and start the initialization. Every time you do a compare or you have to download the memory contents of your GameCube RAM, your GameCube will halt all processes and all operations for up to 45 seconds. So every time you have to make a compare, you're going to waste 45 seconds of your life. Reason being is that there is a lot of information that needs to be downloaded from the GameCube to your computer and then saved as a file. So keeping in mind that the more you search around, the longer it's going to take. So we have an initial dump success, and as if you probably noticed, while it was dumping the memory, it made a lot of god-horrible noises and seemed like it can crash. If your GameCube lasts more than a minute or so, then in that state, you've probably crashed the cube. Now, we're going to go ahead and use some water. Just going to use water, just use some more, use some more. And then over here we have the compare types. We have less, greater than, equal to, not equal to, just like with the NES ROM hacking and the lobotomization. So, we've used some water. That memory address should be less, so we're going to make a compare. Again, the GameCube is going to halt operation. It's going to download the contents of the RAM from the cube to your computer, and this application is going to compare all of the values that were less than before, and then it'll give you appropriate information on screen. Looking at the display window, we see that it's found 825,360 matches. So it wants to display 500 matches or less. So, again, we're just going to use a little bit of water. You know, typical RAM address hacking. You know, change some values around, make some adjustments, make sure the memory values that you're looking for either change or do not change. And we're going to make another compare. Okay, now it only has 247,935. Now this is going to take me some time, so I'm just going to fast forward and get down to a decent amount of values that, you know, we can analyze. Okay, so it took me about 15 minutes and 3 GameCube crashes later. Now, when you're poking and prodding around memory addresses, you have to remember that you're most likely going to crash your GameCube, so if you either are fat and lazy, or you should keep your GameCube close by. Okay, so what I've done is using the equal, not equal, greater than, less than, blah 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 blah, just like with the NES ROM hacking and the RAM hacking. I found 2 memory addresses. Okay, now over here you have the read, write, hex view memory editor box, top right corner. And we're going to take a look at this memory address right here that ends with 21A6. And we're going to read the memory from that. Right now it's a value of 15. Now let's take this, now I know this is the water because I've been experimenting, we're going to drop this down to 0, 0. And you'll notice that there's this button right here, byte. A byte is a 2-character long hexadecimal value. Half word being 4 characters long, and a word being 8. So we're going to keep this down in the byte level for now. So we're going to write this memory value as 0, 0, and it should have dropped the water value. Why isn't it working? Write memory. Oh, there it goes. I guess my video is just like a stupid capture box. Okay, so we'll make this the maximum value at FF. And we're going to write the memory. And boom, there you go. There's your water. Now, using these tactics and techniques, excuse me, you can actually find, you know, coins, lives, energy, this, that, and the other thing. This is just some of the basic stuff you can do. Now, a word of advice is when you're actually going through your memory addresses, click this button that says Save Match when you get down to a reasonable number, because if you don't, you have a good risk of crashing your GameCube and losing all of your work. Unfortunately, you can't load your search back in, but with this address box right here, you can manually look at the memory addresses. Now down here, you have a basic hex editor. And this will quite literally show you all of the hex values in both hex and in ASCII representation of what everything says. So, in the bottom of the screen, you get these stupid DEBS alerts. Now, normally you'd have to read everything in hex, but it just so happens that the values are actually in ASCII. Meaning, if you were to take this file using the Save Dump button right here in the middle left, you can actually save this to a text file and then just use a typical, you know, find ASCII string and search for known strings of text. Then you can find the memory addresses and actually edit those at the bottom. It's a difficult, lengthy process. I'm not going to get into that right now. So I'm going to do a little bit more poking around and see what else I can change in this game. I've done a bit of poking and prodding and searching, and I found the memory address for coins, and this is memory address 80578A63. When we read the memory, it'll confirm that it is in all zeros, as we have no coins. So I have verified that this is the coin, so we'll take this up to 10. Now keeping in mind that this is hexadecimal. So we're going to write our memory, and that's 16 coins. Let's bring it up to 20. Write the memory. 32 coins. There you go. This is the basic search techniques of compare, contrast, you know, get a coin, search for a value that's greater, lose a coin, search for less than. Basics, principles, and techniques that were explained in the NES ROM hacking segments. This can be applied to coins, health, timers, lives, God knows what the hell else. Now, Super Mario Sunshine is a very basic game, and it's got a lot to it, so let's move on to something a little bit more interesting. Legend of Zelda Twilight Princess. You can't have any kind of Nintendo console hacking without Super Mario and Legend of Zelda. So we've got Legend of Zelda Twilight Princess here, and I've actually gone off, this is well before when I was playing the game, I found some memory addresses already, and we're going to punch the values in, and I'm going to show you some of them. So memory address 80408162. We're going to read this. Right now it's got a value of 00. Now we're going to show this in half word, and if you notice that we have, this game uses more half words than bytes and full words. So we're going to drop this down to 00 and see what happens. Oh crap. I guess that was our health, wasn't it? Yeah, that was, in fact was our health. And here we are again. Okay, now we got 3 measly little hearts. We know, in fact, that this is going to be a full word value, so let's bring this up to hex 62. We're going to write memory. Lots and lots of yummy health. Alright, let's see what happens if we bring this up to 70. I guess that's all I can have. Alright, well there's the memory address for health. Typical stuff. Alright, let's do rupees, which should be address 64. And we're going to read memory. Right now we have 04E8, which is 1256 decimal. And of course this is a half word format. Let's bring this down to, you know what, so it doesn't take forever and a day, we'll bring this down just to 0. We're going to write memory. There you go. There's rupees. Here we have the item list for Legend of Zelda. Now, right now I have the lantern selected, as you can see on screen. But it just so happens that every single one of these positions on screen of all of the items, each one of those has a memory address. Each one of those addresses has a value. So right now we're in the lantern address at 804081FD. And when we read the memory value, it's memory value 48. And I've done a lot of searching, and I mean a lot. This probably took me about 3 or 4 hours, and I'm still not even done. Now, I know value 48 is the lantern. But let's say we want the wooden sword. Now, I know that's value 3F, and we're going to write that. Lo and behold, wooden sword. Now we can take the wooden sword and equip it as if it were an item. Normally, you wouldn't be able to do that. Okay, you want the Dominion fishing rod, something else that you really can't get in this game just yet. Okay, memory address for value 4C. Now, of course, these are bytes, not words or half words. So we're going to write that in. The image doesn't change, but the text does. And when we equip it, if you notice the little Y button icon at the top, oh, that's an unequipable item, I guess. Nope, there's the Dominion rod. Okay, hey, you want the Master Sword? Normally you can't take the Master Sword and equip it. That should be memory value 49. Right memory. Master Sword. Now let's go ahead and equip it. There's our Master Sword. Now if we go in game and we try to use it, doesn't let us. It thinks that we have the Master Sword out, but it's a non-equipable item. It's supposed to be a weapon. So this goes to show that all your memory addresses in the game, just like in the NES, can be searched, poked, and prodded with a Viper GC Extreme GameCube mod chip. Now it's a lot more difficult than this, but nonetheless, it is really fun. But there is one more feature that I really like about this chip. I mean, it does a lot more, but let's get into this next feature I want to explain. Because everything is in a client-host mode, the client being the GameCube and the host being the computer, we can initialize server sessions, so to speak. So they have something called Game Remote, which is kind of like, with a very piss-poor analogy, hacking the Matrix. What this allows you to do is, using command line utilities, modify memory addresses in real time, either read them or write them. And because you're reading and writing to specific memory addresses, it takes a lot less time. So I made a couple of batch files, or MS-BAT files. What this is I went into Notepad and I typed in the gameremote.exe and the command line options. The first thing you have to do is start the game by typing gameremote.exe space S. Normally you can do this into a command window, which I can show you now, or I can try to. gameremote.exe S. And this starts up the game. Now I'm going to jump over to the in-game, and I'm going to show you what the rest of these batch files do. Okay, now that we're in-game, you'll notice that I have things like arrows and waterbombs.bat, hearts.bat, and bombs and bomblings.bat. What these files will do is when I click on these batch files, the command line is gameremote.exe O, which means write to the memory address, and then the memory value in full word format. So, if I click arrows and water bombs, this will completely refill all of my arrows and water bombs. This will refill all of my hearts, and this will refill all of my bomb and bomblings, which are items in the game. Which is pretty cool because if anytime you're in the game and you're running around and you get attacked or you get hurt or anything like that, and you need some quick help, you don't have to go and really take your hands off the keyboard for too long. All you gotta do is, once you get hurt, boom, there it is. All my hearts are back. Hearts are back again. And there's really nothing the game can do about it. Because you're poking and prodding memory contents that you shouldn't be. There we go. That's just the basics of GameCube RAM address hacking. There's a lot to it, there's a lot of discrepancies, and it can get very finicky and very picky. But it is something very fun to do if you can get a reliable stream connection to your GameCube. I have a lot of problems of the GameCube going out of sync with the PC, and things just completely failing and having to start over again. So, all I can say is if you have any interest in really nitty-gritty, dirty nails and bloody knuckle console hacking, this has got to be some of the toughest stuff I've ever seen.